Section 5 is all about solving square roots and other radical equations. First thing we're going to talk about is how we can solve equations that involve square roots and why you have to check your answers as part of the process. There are 4 basic steps you need to use when solving equations with square roots or any radicals for that matter. The first one is to isolate the radical, get it by itself. The second one is to raise each side to whatever power you need in order to eliminate the radical. The third is to solve for the variable. And then the fourth is to check your answers. Even though the fourth step seems a little insignificant, it is really important in the grand scheme of things. So step 1, you want to solve for x, you need to isolate the radical. This one is already by itself, so you can go right to step 2. Step 2 is to raise each side to a power to eliminate the root. In this case, the square root can be eliminated by squaring. What you do to one side has to be done to the other. If you square the left, you get x plus 2. If you square the right, you get 25. Solve for x. We're going to do that by subtracting 2 from both sides. We're left with x equals 23. The last step in these equations is to check. That means that I'm going to take that 23 and plug it in the original equation for x. So to check this, I'm doing the square root of 23 plus 2, and I better get 5. Square root of 23 plus 2 means the square root of 25, and that is 5, so it does check. 23 is the answer. Number 2, if I want to isolate the radical, I need to start by subtracting 3 from both sides. Subtracting 3 leaves me with the square root of 2x minus 3 on the left and 5 on the right. Step 2, raise each side to the power. In this case, I need to square both sides. Squaring the left gives me 2x minus 3, and squaring the right gives me 25. To finish solving this, I'm going to add 3 to both sides first, gives me 28. 2x equals 28. And dividing by 2 gives me x equals 14. To check it, I'm going to put that 14 in the original equation. So this 14 right there. I get 3 plus the square root of 2 times 14 minus 3 better equal 8. So inside the radical first, 2 times 14 is 28, and 28 minus 3 is 25. So I get 3 plus the square root of 25 equals 8. The square root of 25 is 5, and 3 plus 5 does equal 8. So this checks. The answer is good to go. All right, number 3. The order of which you isolate the radical here is super important. First thing I need to do, I don't have a choice, is to subtract 2. Subtracting 2 leaves me with 3 times the square root of x equals 3. Then I'm going to divide by 3. I get the square root of x equals 1. That's isolating the radical. Step 2 is to raise. I'm going to raise both sides to the second power to eliminate the square root. I get x equals 1. 1 squared is 1. To check that, I'm going to put this 1 back in the original equation for x. 3 times the square root of 1 plus 2 equals 5, I hope. The square root of 1 is 3, and the square root of 1 is 1, and 3 times 1 is 3. And 3 plus 2 does equal 5, so my answer is 1. In number 4, isolating the radical requires me to subtract 5 first. I'm left with the square root of x plus 7 equals x minus 5. This one's considerably trickier because when I square the left-hand side, I also have to square the right-hand side. Squaring the left just leaves me with x plus 7, but squaring the right means I have 2 copies of the binomial x minus 5. So if I recopy the left-hand side and FOIL the right, x times x is x squared. X times negative 5 is negative 5x. Negative 5 times x is another negative 5x. And negative 5 times negative 5 is positive 25. So in the next step, I'm going to do a whole bunch of things. I'm going to combine these 2 like terms. That's x plus 7 equals x squared minus 10x plus 25. And then, because this is a quadratic, my next step is to set it equal to 0 so I can solve. which means I'm going to subtract x and subtract 7. Make a note of the fact that when I subtract x and I subtract 7, I subtract them from their like terms. I end up with 0 equals x squared minus 11x plus 18. Back in chapter 4, we learned that there are several ways that we could solve this quadratic. Your gut reaction probably says quadratic formula, but remember, the easiest way is to solve by factoring if you can. You definitely can factor this. Two numbers that multiply to 18 and add to negative 11 are negative 9 and negative 2. If that's your factor, then your solutions are positive 9 and positive 2. You do need to check them both, so that means I'm going to take a 9 and I'm going to take a 2. I'm going to put them in the original equations for x. So that's the square root of x plus 7 plus 5 equals x. So when I check the 9, that means I'm going to do the square root of 9 plus 7, go back up and check it, plus 5 should equal 9. 9 plus 7 is 16, and the square root of that is 4. 4 plus 5 equals 9. That one's good. I'm going to check a 2. The square root of 2 plus 7 plus 5 better equal 2. 2 plus 7 is 9, and the square root of that is 3. 3 plus 5 does not equal 2, which means 2 doesn't work. Only 9 does. Sometimes that happens. It's not the first time we've seen answers not work in our original equation. Speaking of answers that don't work, that's common. Sometimes when you check your answers, it becomes really, really important to always remember to do that because we get what are called extraneous solutions. The first time we saw extraneous solutions was back in absolute value equations, where we would get 2 answers after we forced stuff to be positive, and one or both didn't check. So in order to check them, you're looking for any value that you find that makes the original equation true. If it makes it false, it's extraneous, and you end up throwing out the solution. So the directions are almost the same here. They're just going to tell you to be sure to check for extraneous solutions. In number 5, on the left-hand side, that fractional power of 1/2 is really the square root, and it's already by itself. So I'm going to start right away by squaring both sides. Squaring the left-hand side leaves me with x plus 11, and squaring the right leaves me with 36. Make sure you put parentheses around the -6 in the calculator. To solve that using algebra, I subtract 11 from both sides and I get x equals 25. It's important that you check that 25, so I'm going to put that back into the original equation. That means 25 plus 11 to the 1/2 power should equal, -6. Fix that just so it's clear. So on the left, 25 plus 11 is 36. 36 to the 1/2 should equal -6. 36 to the 1/2 is the square root, and the square root of 36 is positive, not negative, so that doesn't work. 25 is not a solution, and since there are none left, this is a no solution. 25 is extraneous. In number 6, I have to isolate the radical first, and in order to do so, I'm going to add 5 to both sides. Gives me the square root of x plus 7 equals x plus 5. Isolate first. Step 2 is to raise. I'm going to raise both sides to the 2nd power. On the left, I have x plus 7. On the right, I have to FOIL x plus 5. If you FOIL and combine like terms on the right-hand side, you would end up with an x squared plus 10x plus 25. Anytime you want to solve a quadratic, get it equal to 0. So my next step will be to subtract x and subtract 7. I end up with 0 equals x squared plus 9x plus 18. This should be looking very familiar to you. This is a problem we had done together earlier. This factors into an x plus 6 and x plus 3. So x equals -6 and -3. Just as important as solving these questions is checking these questions. So I need to check both the negative 6 and the negative 3. I'm going to check the negative 6 first. Into the original problem for x. So I got the square root of negative 6 plus 7 minus 5 should equal negative 6. Negative 6 plus 7 is 1, and the square root of 1 is 1. 1 minus 5 equals negative 6. It doesn't, so negative 6 is not a solution. I'm going to check negative 3. The square root of negative 3 plus 7 minus 5 should equal negative 3. Negative 3 plus 7 is 4, and the square root of 4 is 2. 2 minus 5 does equal negative 3, so it checks. Negative 3 is my only solution because negative 6 was extraneous. In the you try it, you get 12 or 3, but 3 doesn't check, only 12 does.